Hello, geometry. Here we go with the second lesson in Unit 10. Today, we're finding the area of a circle as well as portions of a circle. So last lesson, we looked at the outside of a circle, circumference, right? And portions of it. Today, we are looking at the inside of a circle, which we call the area. All right. So we're not going to be looking at just a full circle. We're going to be looking at parts of it. If we were doing a full circle, that'd be middle school like material. We're looking at portions. So the shaded region in this picture here, circle 0, circle O, is called a sector. Think of it like a slice of the pie. Okay. To find the area of this shaded region or this sector, we think of it as a fraction of the area, right? Just like yesterday, we said the arc length was the fraction of the circumference. Area of a sector is the fraction of the area. The area of a circle, just in general, the full circle, is found by using the formula pi r squared. The fraction comes from the measure of the arc. All right, so just like arc length, the beginning of the formula matches exactly. So the measure of arc AB divided by 360. That should look very familiar to what we did yesterday. But then instead of multiplying it by 2 pi r, we multiply it by pi r squared. That's the only change with this formula. Okay, so let's do this problem. So the measure of arc AB is 120 out of 360 times pi. The radius here is 9 squared. So 120 and 360 reduces to 1/3 times 81 pi. So I got 81 pi over 3, which reduces to 27 pi. And that would be units squared. Okay, so that's leaving your answer in terms of pi. And there you go. A couple more practice problems here with the sector idea. Most people do okay with this. It's the stuff on the back that people have trouble with. So the measure of the arc. Now there's no AB here, but you know what I'm talking about. So it's 60 degrees divided by 360 times pi r squared, and r is 8 here. So 60 and 360 reduces to 1/6 times 64 pi. So I get 64 pi over 6, and I believe that that reduces. Take 2 out, I get 32 pi over 3. And that would be, again, units squared. Right. Next one, the measure of the arc is not 90. A lot of people look at that and say 90. That's the unshaded. We want to go from here around this way, which is 360 minus 90, or 270. Times pi. The radius here is 7. Hopefully you caught that. The 14 is the diameter, so the radius is 7. So I got 3/4. 270 over 360 reduced to 3/4 times 49 pi. Multiply across, you should get 147 pi over 4, which actually does not reduce. So that's my answer, 147 pi over 4. And this one's going to be feet squared. So hopefully not too difficult there. It's very, very similar to what we did with arc length. The backside combines this with something that we did in the last unit. So I'm going to go ahead and clear this and move to the backside. All right. Segments of a circle. So a segment of a circle is the area within a circle bounded by two things. So basically, the two things that create this are, first of all, an arc. And the second thing is the segment joining the arc's endpoints. So I've got the arc, and then the segment connecting them makes my segment. So the shaded region represents a segment of circle C. To find the area of a segment, you need to find the area of the sector So keep in mind what a sector is. It's that whole slice. And then subtract the area of the triangle. So I'm going to point out this triangle here. We're going to subtract that. And that what's left is the segment. Okay. I said in this picture, it is triangle CAB. So we're going to go ahead and find the area. I'm going to go ahead and clear everything right now and scroll down a little bit, and then I'll show the work. All right, so the sector, just what we did on the front. So the measure of the arc is 120 over 360 times pi r is 24 squared. So I'm going to go ahead and simplify that. So that's 1/3 times 24 squared, I think is 576. Yep. 576 pi, which I do think divides. Yes, it does. So that's 192 pi. But that's not my final answer. That's this whole thing up here. I don't want the whole thing. I want to subtract that. All right, so I'm going to go ahead and get rid of all that shading there. I'm going to subtract the area of the triangle. Now, what's the area of the triangle? Some of you are going to say 1/2 base times height. You'd be correct, but that's going to be really challenging here. I wish there was a different formula for area of a triangle. There is. If you remember lesson 6 in the last unit, I talked about how you could do 1/2 BC sine A. You may not remember that formula, but it is something that I taught. It's very, very helpful here because I know this is 24, which means CB is also 24. I have two sides and the angle between them. So the area of this triangle is 1/2 24 times 24 times the sine of 120. All right, I'm not going to round until the very end. So I'm going to do 24 times 24 and then divide that by 2. I get 288 sine 120. So if I'm writing this in terms of pi, I have 192 minus sine 288 sine 120. So that would be my answer in terms of pi. However, I did say give it to the nearest hundredth, so now I can type it in the calculator. So 192 pi, make sure you use the pi button, minus 288 sine 120. And I get 353.77. And that's the area of that region. And that would be units squared. All right. You will have to know how to do that. The next one, the next two, I wouldn't ask you anything like this on a test, but it is good to see. I could show you 2 ways of doing number 1. The first way would be the area of the whole circle minus the area of the segment. I think this is tough because what you're going to be doing is you're going to be doing that whole thing we just did in the previous problem, but then you have to subtract that whole thing from pi r squared. I don't like this way, but you can do it. Well, real quick, the whole thing would be everything including this, and then I would subtract the area of that. I don't like that way. I like the area of the sector plus the area of the triangle. The sector being the part that I'm coloring right now. And then the triangle being the stuff that I'm coloring in orange. Right. So I'm gonna go ahead and do that. I'll do the sector in red and I'll do the triangle in orange. So the sector, I have a 90-degree angle there. So this is 90, but I want the other way. So 360 minus 90 is 270 over 360 times pi times 18 squared. So that's 3/4 times 18 squared is 324. Yep. 324 pi. So 324 pi times 3 divided by 4 gives me 243 pi. That's the sector. But then I have to add the area of the triangle. The area of the triangle is 1/2 BC Well, that's 18 and 18 times the sine of 90. Good news is the sine of 90 is actually just 1. Okay, so 18 times 18 divided by 2 is 162 times the sine of 90 is just 162. So I'm taking 243 plus 162, and it wants it in terms of pi, so that's what I'm going to write. 243 pi plus 162, can't put those together, and that's going to be feet squared. Oops, not feet, 0.2. Back that up, feet squared. There we go. Okay, last one looks awful, but when I show you how to do it, you're like, oh, it's really not that bad. Okay, I've got this as 8 and 8 are on opposite sides, which means it's the diameter of the circle, which means that the radius there is 4, which means the radius there is 4, which means the distance across here is 8 and 8. Okay, I haven't taught this yet, but those are actually right angles, so I can say that this is a square. So to find the area of the shaded region, I'm going to find the area of the square, and then I'm going to subtract the area of 2 equal semicircles. Those 2 semicircles are the same. Okay, so the area of the square should be pretty easy. It's just 8 times 8, so 64, minus the area of 2 semicircles. Well, a semicircle is half a circle. So pi r squared is a full circle. Half of that would be 1/2 in front. But there's 2 of them, so I'm going to multiply by 2. Well, what happens then? Well, the 2 and the 1/2 cancel, and I'm left with 64 minus pi r squared. The 2 semicircles make a full circle. So 64 minus pi, and the radius is 4 squared. So it's 64 minus 16 pi is the area of that shaded region. And it's feet squared. Okay, so again, 1 and 2 are a little more than you need to know, but it was good to see how it's used. Okay, what you will have to do is what was on the front and the segment at the top of this back page. Okay, that is the lesson, and we're going to move on to some other stuff with circles in the next.